Thanks for watching. If you enjoyed this video, please hit the subscribe button and ring the notification bell so you never miss an update. Leave a comment below to help grow the channel, and don't forget to smash the like button. Okay, welcome back to Lecture 8 on Introduction to Fractions. So let me remind you of a very simple division problem. 8 divided by 2 is equal to 4. Why? Well, because 4 times 2 is equal to 8. And we can look at this problem if we were to think of 8 circles. 2, 3, 4, 5, 6, 7, 8. The problem 8 divided by 2 is basically saying take these 8 things and divide them into 2 sets, right? So I could put a dividing line right here where I could call this set 1, I could call this set 2. And so you see that the answer to a division problem like 8 divided by 2 is 4, the number of objects in each set. I could, if I wanted to, write this number 4 as 8 over 2. When we think of division, we think of the 8 as the dividend, and we think of 2 as the divisor. But when we come up with this new number, right, this new kind of number, which we call a fraction, we change the terminology, right? So we call the piece upstairs the numerator, and the piece downstairs the denominator. And part of this lecture, I'm going to explain why we choose those names. But first, I just want to put out the idea that instead of writing 4 like this, we can write it in terms of a division problem like this. And so you're asking, well, why would I do that? Well, what if instead of 8, we had 7? Well, it's certainly not going to be equal to 4 anymore, right? So, and we're not going to have 8 sets here, right? We only have 7. So what do? Well, we can't have the 2 sets be unequal. Okay, so what we're going to do is we're going to take one of those out and we're going to put it aside over here. And so this says that 7 divided by 2, well, we can get 3 in one set and 3 in the second set, but we've got 1 left over. We call that a remainder in our division problems, right? So what is this equal to? Well, this is equal to, let's just go back and look at our division problem. We would take 2 and we would divide it into 7. And we could go into 7 how many times? Well, 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. We've gone over. So let's use 2 times 3. 3 times 2 is 6, leaving us with a remainder of 1. So this is 3 remainder 1. This, however, is not a very convenient way to write numbers. 3R1. However, a perfectly fine way to write a number is like this, 7 over 2. So now 7 over 2 is a number which cannot easily be expressed in terms of whole numbers. So fraction, what does fraction mean, right? Think of words that you hear the frac in, like fracture, right? What does fracture mean? If I fracture a bone, what happens to my bone? It breaks, yes. So you can think of fractions as broken numbers, okay? So in this case, I've broken 7 up into 2 sets. But we cannot easily express that in whole numbers because we would have a remainder, right? So this is kind of the motivation behind creating a fraction in the first place. Now, there are 2 types of fractions, proper fractions and improper fractions. And I'm going to show you the difference now. But first, let me just point out that 7 halves, because the numerator is larger than the denominator, we would call this an improper fraction. So improper fractions are when the numerator is bigger than the denominator. Just out of curiosity, if the numerator was equal to the denominator, what would that be? So if I gave you a fraction and I said, how about 8 over 8? Well, remember, this is just a division problem, right? So we can do this division problem. And we would say, okay, I'm going to take 8 and I'm going to divide it into 8. How many times is 8 going to 8? Well, 1 times 8 is 8. Leaves me a remainder of 0, so it's 1. And so we see a really funny thing with fractions. We can write a number like 1 in many, many different ways, because 8 over 8 is 1, but so is 9 over 9, and 10 over 10, and 11 over 11, and 12 over 12. There's an infinite number of ways to write the number 1 using a fraction. And we'll use that to our advantage later. But that's the special case where the numerator is equal to the denominator. If it's greater than the denominator, we call it an improper fraction. Now I want to look at proper fractions in kind of the traditional way. So let's look at a proper fraction. So we need a numerator which is smaller than the denominator. So we'll do something like 1 over 2. So that is the problem, 1 divided by 2. Now, of course, 1, I mean, how do I divide? Here's my 1. How do I divide that into 2 pieces or 2 sets? Well, I can't, right? There's only one of them. So if I'm going to divide it into 2 sets, I would have, what would it look like? It would look like one set with no, this is set 1. We have no circles in it. And then set 2, we also have no circles in it, but we have a remainder of one of these things over here, right? So this is kind of the province of proper fractions. There are no whole numbers in a proper fraction. And a way to think about it, at least the way I like to think about it, is in terms of pizza, because I like pizza. So imagine a pizza. And if I cut it in half, I would have 1 slice and 2 slices in the whole pizza, you see? So the whole pizza we think of as the whole, or 1. And the denominator kind of tells us how many slices we cut the pizza into. I don't have to cut it into 2 slices, I could cut it into 4 slices. So let's consider 1 over 4 over here. So here I've got my pizza and I cut it into 4 equal size slices. That's important. The slices have to be equal size, okay? So a half, 1/2 would be this, whereas 1/4 would be this. So now you see the origin of this numerator part. It tells numerator num, right? It tells you the number of halves, or the number of quarters, right? In 1/2, there's only 1/2. In 1/4, there's only 1/4. I could, if I wanted to, write 2 quarters. My numerator would then be 2, and that would represent this, 1/4, 2 quarters, 2 quarters, yes? Now, this brings up an interesting point, though. These two things look the same, don't they? If I said, would you like 1 slice of a pizza cut into 2 slices, or half of a pizza, or would you like 2 slices of a pizza cut into 4 slices, or 2 quarters? If you look at it graphically, you can see that they're exactly the same number, yes? So that means that 1/2 must be equal to 2 quarters. Well, that's interesting, huh? So we see graphically why that is, but can we find a way to demonstrate it mathematically? Well, let me show you a little trick, or a technique rather. This is called cross multiplication. And the way it works is this. So if we want to test if 2 fractions are equal to each other, here's how we do it. So we write the first fraction, and then I'm going to write an equal sign with a question mark over it, okay? That means that I'm testing whether these are equal. And then I put the second fraction on the other side of this equality, or this hypothetical equality. Now the cross multiplication, what it says to do is it says take the numerator of the fraction on the left and multiply it by the denominator of the fraction on the right. And take the denominator of the fraction on the left and multiply it times the numerator on the fraction on the right. That sounds like a mouthful, right? But if you think of it like this, the cross part, think of a little cross like this. So what we do is we rewrite this as 4 times 1, question mark, equals 2 times 2. So I just took this 2 and I moved it over here. And I took this 4 and I moved it over here, and I'm multiplying them. And so I multiply these two terms, what do I get? I get 4 times 1 is 4, and I get 2 times 2 is 4. Now is 4 equal to 4? Yes. Yes, it is. And so I can erase the question mark because I've now established that that's equal. And now if these are equal, if what we get after cross multiplication is equal, that means that what we started with is equal as well. So I can erase the question mark over the equality here, and I can then definitively say, because of the cross multiplication check that I did, that 1/2 is equal to 2 quarters. Let's test this by considering some fractions that we don't know. This we kind of set up. We could see graphically that they were equal. I showed you the cross multiplication technique. Now let me give you a couple of other fractions that you may not know whether they are the same or not. 3/8 and 5/8. So pause the video, use the cross multiplication test to see whether or not these two fractions are equal to each other, and then come back. Okay, so let's do cross multiplication on this. Again, cross multiplication involves taking the denominator of one side of the equality and multiplying it times the other side, and vice versa. The same thing with this one. So we'll get 8 times 3 and 5 times 8. 8 times 3, can someone tell me what that is?
24.
24. And 5 times 8, can someone else tell me? 40. Now, is 24 equal to 40? No, it is not. So we can definitely say that these two are not equal to each other because 24 is not equal to 40, which means that 3/8 is not equal to 5/8. You see that? We can go further if we'd like, right? Because we see that 40 is greater than 24. Well, I don't know if you've ever seen inequalities before, but equalities involve writing an equal sign, okay? An inequality is another symbol that we write that expresses which one is the larger number. And the rule is that the inequality always opens up toward, if you think of it as an alligator, and the alligator always tries to eat the bigger number. So instead of having an equal sign, I can write this little alligator mouth like this. You see? He's trying to eat the bigger one. And this reads that 40 is greater than 24. Or you can say it another way, that 24 is less than 40, which means that 3/8 is less than 5/8. Now that is probably not terribly surprising because we could have done this graphically. We could have taken a pizza, cut it into 8 slices, so we have to half it and then half it again. That gives us 4 slices, and then we could half each of these slices. And we get 1, 2, 3, 4, 5, 6, 7, 8 equal-sized slices, yes? Now if I have 3 slices of an 8-slice pizza, that looks like this. There's my 3 slices. Remember, the denominator tells you how many slices one pizza is cut into, and then the numerator tells me how many of those slices I have. This is 3/8. What about 5/8? Well, let's make another pizza with 8 slices. And let's get 5 slices of this. That's 1, there's 2, there's 3, there's 4, there's 5. So you can clearly see that 5 slices of a pizza cut into 8 slices is more than 3 slices of a pizza cut into 8 slices. Yes? Okay. Now you may have noticed in that last problem that we tried that the denominators were exactly the same. And that made it easy to graphically think about the problem and come up with an answer, yes? What if they were different? What if instead of 3/8 and 5/8, I was comparing 3/8 and 4/9? The denominators in this problem are different, but the cross multiplication technique still works just fine. So go ahead and pause the video, give that one a try, come back and see if you can tell me whether 3/8 is less than, equal to, or greater than 4/9. Okay, so we'll apply the cross multiplication technique. So we'll get 9 times 3, question mark, equals 4 times 8. And what is 9 times 3?
27.
27. And what is 4 times 8? 32. And we know that 32 is greater than 27, so the alligator's mouth opens like this, which means that 4/9 is bigger or greater than 3/8, which means that they are not equal. Let's go back to that pizza where I cut it into just 2 slices. Just cut it in half. If I were to say, if I doubled the number of, so if I gave you 1 slice of this pizza, and I said, hey, I tell you what, I'll double it. The amount of pizza I gave you, I'm going to double that. How much pizza would we have now? So if instead of giving you just 1 slice, what if I said I'd double the number of slices that I give you?
Now I have 2 slices.
But 2 slices of pizza cut into halves would be a whole pizza, right? And so 2 times a half must equal 1, yes? Because what is multiplication? Does anyone remember that multiplication is just repeated addition? Yes? So what does, we can reverse these things. And instead of saying 2 times a half, I can say a half times 2. that would tell me that I'm going to add a half to itself 2 times, right? So that's 1/2 plus 1/2. So apparently, the rule for this must be that when I add fractions, and if the denominator is the same as they are here, then I can just add the numerators. So we'll have this, and we'll have 1 plus 1 in the numerator. Does that make sense? So what is 1 plus 1? Well, that's just 2. And 2 over 2, well, this is a division problem, don't forget. 2 divided by 2 is just 1. So this is just equal to 1. And I think that makes intuitive sense, right? If you have a pizza, let's go back to our 8-slice pizza. And I were to first give you, say, 2 slices. So first I give you 2 out of the 8 slices, or 2/8 of a whole pizza. And then I say, you know what? I'm going to give you 3 more slices. Three more slices. So how much pizza do you have now? Well, you can count it up. We got 1, 2, 3, 4, 5 slices out of 8, so we should get 5/8 of a pizza, yes? So that means that when I had 2/8 that you had initially, and then we add another 3/8, you see this is just an addition problem. 2/8 plus 3/8, since the denominators are the same, I can just add the numerators. And we get 2 plus 3, 5/8. So when adding fractions, if the denominator is the same, it's a really easy thing to do. It's just you add the numerators. And what do you think you do for subtraction? If the denominators are the same, subtract the numerators. So let me give you a problem like that. So go ahead and pause the video, try this subtraction problem involving fractions, and then come back when you've got it. So what we learned is that we can just simply write both of these under a common denominator of 16, right? Since they both share that denominator. And then we just subtract the numerator. So we have 7 minus 2 in the numerator. And what is 7 minus 2?
5.
5. And so 7/16 minus 2/16 is just 5/16. Pretty straightforward, yes? Okay. Okay, I want to return to improper fractions. We started off with an improper fraction when we talked about 7/2 before. So let's look at improper fractions again. But let's look at the following. The pizza problems that we were doing, where I said if I doubled the number of slices that you got, so you took 2 times a half, you got that was equal to a whole pizza, right? What if I said I'm going to multiply the number of slices that I gave you 8 times over? So I'm going to give you 8 times as much pizza. Well, that's just 8 times a half. Yes? And so a whole number times the fraction, right? If we think of it as pizza, right, that just means instead of just 1 slice, I'm going to get 8 slices, yes? So this is equal to 8 over 2, or 8 halves. I'm just kind of dropping the terminology on you. Halves and quarters, this all kind of comes from, dealing with money and things like that. You should have some familiarity with it. You've probably heard it before, quarters and eighths. The rule is that for the piece in the denominator, right, we always put a th at the end of it there. So, except for a half, of course, and a quarter. Those are special. But if it was, a fifth or a sixth, if I had a 6 in the denominator, it would be a sixth. You put the th at the end. So, not a big deal. You've probably heard it before, but I just mentioned it because I just noticed that I've been using the terminology and I didn't really explain it. Anyways, back to 8 halves. Well, we can, again, it's a division problem, and we can do division. Can anyone tell me what 8 divided by 2 is? What is it?
4.
Yes, it's 4, right? So we get a whole number answer here. So that's interesting, right? So we multiply 8 times a half, we get a whole number answer of 4. And that makes sense because if we think of our pizzas cut into halves and we get 8 of those slices, right? The first 2 slices makes a whole pizza. Then we get another 2 slices making a second whole pizza, and then another 2 slices making a third whole pizza, and then finally another 2 slices giving us a 4 pizza. So we see that we get 4 pizzas, right? If we have 8 slices and it was cut into halves. Let me do what we did before and replace that 8 with a 7. What do we do now? Certainly not equal to 4. What is it equal to? Well, of course, that was the whole point of writing 7/2 in the first place, is we can think of this as a number, right, and just write it like this. But there's other ways that we can write it. If we do the division on it, I think we already saw this, right? We divided 2 into 7. It went 3 times with a remainder of 1, right? Now, there's a way to write 7/2, an improper fraction, a little bit differently. We call this a mixed number, okay? Because it has some whole number part to it. A proper fraction has no whole number part to it. It's always less than 1. But an improper fraction does have a whole number part to it. And in this case, the whole number part is 3. So we can write this as 3 plus 1/2. And we can see that if we simply take 7/2 and put them together. We take, here's a half, and then here's another half. Put 2 halves together, that's going to be 1. And then we take another half, and then another half. Now, so far we have 4 halves. That's 2. And then we take another half, and another half. That's now 3 whole pizzas, but we have 3 times 2 slices, or 6 slices, and then we have another half. Yes? So we get 3, 1, 2, 3, plus a half. Does that make sense, the way that we wrote that? So the remainder, if you look at a division problem, the remainder is going to be the numerator. The denominator will always be the original denominator, right? So if we're dealing with 7/2, when we write it as a mixed number, we'll have the whole number part plus the remainder over the original denominator. I think it's easier if you just try a problem. You'll start to get the gist of it. So let me give you a problem. 13/7. So 13/7 is obviously an improper fraction because the numerator is bigger than the denominator. Can you write this as a mixed number? Pause the video, come back when you have your answer. Okay, so how do we do this? Well, we have to divide 7 into 13. So we'll do a long division problem. We'll divide 7 into 13. 7 only goes once into 13 because 7 times 2 is 14. So it almost goes in twice, but not quite. So 7 times 1. And what is 13 minus 7?
6.
It's 6. Remember, your remainders, when you're doing long division, always have to be smaller than the divisor, right? If it's not, that means you can get another 1 in. Okay, so if we got 7 as a remainder, we say, oh, we should have got 2 in there. Must have been 14. Anyways, so we get a remainder of 6. We have 1 remainder of 6. And so the way that we translate this into a mixed number is we write the whole number part, 1, plus the remainder in the numerator and the original denominator. So it's 1 plus 6/7. Mixed numbers are often a better way to think about a fraction if you need to use it in like real life, right? If I want to know, like, well, how many pizzas is that going to be for me to carry in my car? Well, 13/7, I may not know. I'm going to be like, well, 13 pizzas would be too much. I couldn't carry that. But, 1 and almost another one, that's almost 2 pizzas. You can see that quite clearly from this, yes? And so this is often the better way to write the number if you're trying to use it in real life. If you're going to have to do more work on it, right, if you're going to maybe multiply it times something or add it to something, you probably want to keep it in this form. But so improper fractions can be expressed as a simple, as a fraction like this, or as a mixed number. Let me throw one more thing at you that is often confusing for people. A lot of times people write a mixed fraction like 1 plus 6/7 as 1 and 6/7 right next to it, like this. And so, but this and this are equal. You just read this as 1 and 6/7, and the and you think of as just a plus. So this is the way that people oftentimes write it. It's a good way to save space, but it can be confusing because you might think, well, does this mean 1 times 6/7? I'm not sure what this is. But this is just another way to write a mixed number. But it just is exactly the same as this. So you can, if you see it written like this, just translate it into this, 1 plus 6/7. And then you can start to work with it. And we'll work more with mixed numbers after we learn how to add numbers with different denominators. So, and I don't think I ever mentioned what denominator means. I mentioned numerator because it's the number of slices, right? The denominator has a Latin root which means name. Okay, just like money has denominations, right? If someone says, what denominations would you like your change in? You'd be like, make it, tens or fives. You need fives. It means you want $5 bills. That's a denomination. A $5 bill is a denomination of money. It's still equal to $5, and $1 bills are a denomination, but it's not the same as a $5 bill. So it's the name, you see? And so you can think of it as when I have a pizza and I say I've cut it into 7 slices. Boy, that would be tough to make 7 slices, equal size slices. But if you did it, right, you're calling that a pizza that's cut into 7ths. And so that's what the 7 down here means. That's the name. You see? Does that make sense? Yeah. Okay, so we've learned how to compare fractions using the cross multiplication rule. We've learned how to add fractions that have, add and subtract fractions that have the same denominator. That's fairly straightforward because it's just adding numbers. And we learned how to write improper fractions as mixed numbers. The next time we're going to talk about adding and subtracting fractions that have different denominators. See you then.